Hi everyone, I hope all of you are doing great. So in today's lecture, we're going to talk about a question called best time to buy and sell stock with transaction fees. Right. So this is the second last problem of this whole buy and sell stock series. Let's quickly talk about the question and then try to solve this. The question says that you are given an array prices where prices of I is the price of the given stock on the ith day. Similar to what we have done in every buy and sell stock problem. Similarly, this here as well, the same prices array they are giving us. Uh, Another integer is given to us which is called fee, right? Some extra integer they are giving us in this particular problem which is called fee. So question is plain and simple. You have to find the maximum profit you can achieve, and you may complete as many transactions as possible. Like infinite transactions are allowed in this particular problem, but something else is there which we need to focus on. That is, you need to pay the transaction fee for each transaction you do. In this particular problem, whenever you are doing a transaction, right, of course you're going to gain the profit, whatever is the profit associated with that day's price, but you'll also need to pay some amount of transaction fee, right? So you can say out of the overall profit you'll have to reduce the transaction fee, whatever whenever you did the transaction. By completing a transaction, we definitely mean first buying and then selling. Transaction is in steps. Transaction is not a single step. So you buy and then sell. This is one transaction, and once the transaction is completed, you need to pay a fee for that transaction. So with this transaction fees in mind, we'll have to calculate the best profit we are able to make with all the as many as transactions as possible we can do, right? So this is the whole problem. The only thing is that this is just buy and sell stock infinite transaction, but with we are having some transaction fee involved. Whenever you complete a transaction, you need to pay that fee. With this transaction fees, you need to calculate the best profit you will be able to make out of the whole price. So to understand the question better, I've taken this small array. Let's quickly understand what the question is trying to say, and then we're going to proceed with the recursive approach. So according to this array, right, if you see here, the best profit I'll be buying is that, let's say I buy the stock on first day. I have one stock, and keep in mind that I can only hold one stock at a time. I cannot keep piling up stocks. No, I cannot buy multiple stocks here, right? If I am allowed to buy multiple stocks, then I can make as much profit as I want, right? But you are only allowed to hold one stock at a time. So I am having this stock now. So I am having this stock. On the 8th day, I'm going to sell this stock. So what is the profit did I make? I made a profit of 8 minus 1, which is 7. This is the whole transaction. But let's say the transaction fees is 2. Right? Let's say the transaction fee is 2. What am I going to do? After a whole transaction is completed, what comes to my pocket is 7 minus the transaction fees, which is 5. This is what actually I'm going to gain out of this transaction. So this is what transaction fees meaning. Once a transaction is complete, you reduce the you deduct the price of the fee, and then that is the thing you have in your pocket. Okay, one transaction is complete. This is the profit I'm having. Let's move forward. Let's say I buy on 4th, like when the price is 4th. So I'm already in a loss of 4, and then I sell on 9. I sold at 9, I bought at 4. What is the overall profit I made? That is 5. But what is the net profit I'm making is basically after reducing the transaction fees, which is 5 minus 2. And this turns out to the net profit I'm making is 5 minus the transaction fees, which is 3. What is the overall profit I gained, with this transaction fees out of all these prices area? That is 5 plus 3, which is 8. So this is which is going to be the answer for this particular test case. When this is the prices area and this is the fee you'll have to pay for when the transaction is complete. Now this might come as a doubt. See, transaction fees is always the same, right? Uh, it might come up as a doubt that are we giving different fee for a different transaction? No, transaction fee is going to stay constant. Even if you are transacting one time, or let's say 10 times, all those 10 times this transaction fee will be same, right? So I hope you got the question, what the question is trying to establish, right? Let's quickly see the recursive approach and then move on. So I've written the indexes here for this particular test case. Let's quickly get right into the recursive approach of this problem. So in the recursive approach, since you always know that recursion is top-down approach. In a top-down approach, what parameters are we going to take in recursion? That is the most important step in deciding how the approach is going to turn out. First parameter is definitely the index which I'm standing on. So this is the index which I'm standing on. And the second parameter will be what state I'm currently in. Right? which state I'm currently in. Now state can either be 0 or 1. 0 means we are in a buy state and 1 means that we are in a sell state. Correct. So, this is what, these are the two parameters which I'm going to take, index and the state which I'm currently in, right? And this is the array I'm having. Since recursion is top-down approach, what we're going to say is that we are going to start from the last index. We are going to say that if I am going to sell on the 4th day, right, we are going to consider the selling day as the, last profitable day. And that is a fact that always a selling day will be the most profitable day. Why would you want to consider this as a buy day? There is no day after it on which you can sell this. So always consider selling day as the last, the most profitable day in the end. So we are starting from top down approach. So we are already starting from the last. So we are going to say that 4 is going to be the selling index and the state is going to be 1, since we are saying that we want to be in a selling state. Right? Just bear with me a little bit more. Once you'll get the hang of the whole algorithm, you'll understand what I'm trying to establish. It is as similar as, you can say infinite transaction problem. Nothing actually has changed in this particular kind of problem. Let's quickly see to it that what's actually it's saying. So 4th index I'm standing on and state is 1. Now, according to the 1 state, either I can sell on this day or I can ignore selling on this day. If I sell on this day and if I do not sell on this day, if I sell on this day, what is the profit I'll be making? I'll be making, let's not talk about profit right now. If I sell on this day, the previous day has to be a buy day. The previous day has to be a buy day. So previous day, let's say day 3, I'll be standing on the 0 state. And if I do not sell on 4th day, if I ignore selling on 3rd day, my state will going to be same, right? But my day is going to be, you can say, reduced. So 3rd index, but with the same state. Got it what I'm trying to say? Again, I'm going to repeat. If I actually sell on 4th day, the previous day has to be a buy day. Previous day, by previous day, we don't necessarily mean that we are going to buy on this day, hard coded. No, it can be any previous day. If I have sold here, any of these days has to be buy day. But if I'm not selling on this particular day, right, then I'm still maintaining my state. I've not actually exhausted my state. So I'm still maintaining my, sell state, and that state is going to be transferred over to the previous day. Okay, let's move forward. On 3rd day, I am again having two options. Either I can buy or either I can actually buy or I can ignore buying. Since this is a buy state, right? I'm not talking about selling here. I'm talking about buy here because the state has not changed. Let me refactor it a little bit. If I buy, if I do not buy. Let's quickly, go forward with this only, with one side only. Oh, oh. Here, what I'm going to say is that when we are going like previously, right? If we are buying on this day, before this day, previous days has to be a selling state. So day is going to be reduced. Plus, if I am exhausting this particular state is going to be changed. The previous day has to be a buy day. Sorry, sell day, because I cannot buy multiple times. So if I have bought here, the previous day has to be a selling day. Right? Okay. Here you can say, if I'm not going forward with the buying transaction, 2 is this index I'm going to be, but I'm going to maintain my state. Now, if you observe closely, we are exploring all the possible options, right? What are the options? If I'm selling on 4th day, right? Either I can actually buy on this day, this is the actual route, or I can ignore buying on 3rd day and try to buy on 2nd day. So this is, what I'm trying to establish is that all the possibilities we try to cover when we are doing recursion, right? Let's move forward a little bit. So we are on this particular day. If we go behind, like if we actually, and let's say 2, we are on the 2nd day. I can either sell or I can ignore selling. If I actually sell, if I ignore selling, if I actually sell, day is going to be 1, but the state is going to be changed. But if I don't sell, the day is going to be 1, state is also going to be 1. Let's move forward more in this direction only. First, since recursion is there, so we are going to complete one direction first, right? Here, what we are trying to do is we are going to try to buy the stock on the 1th day, right? Since state is 0. Now, either I can go ahead with the buy transaction or I can ignore buying today. I'll try to postpone the buy, right? So actually in this case it should be prepone, but okay. So 1 comma 0, if I'm actually buying, right, the previous day has to be a selling day, right? If so, this turns out to be, I'll go on index 0 and the state will again be 1 because state has changed, right? Whenever we are actually going ahead with the transaction, now you can observe that state is getting changed, right? But if we are not going ahead with the transaction, this particular transaction, then the 0th day will be considered as the buy day. Now, one thing you have to make very clear is that 0th day cannot be a selling day. This is actually an invalid test case. You cannot sell on 0th day because you have no profit gained. So if you are on the 0th day, no matter what, right? And if you're in a selling state, you're going to return 0 from here. That no profit was gained because 0 is actually not actually a place where you can sell, right? You need to buy first before selling. And this is invalid, right? 0 comma 0, yes, I can buy on 0th day. If I buy on 0th day, what I'm actually going to plan is, what I'm actually planning, if I buy on 0th day, I'm going to return what? Since I'm buying here, so I'm going to return -1 here because this is what I have spent. So from here, let me use a different color, and from here I'm going to return -1, right? So -1 is the profit return if I buy on the previous day. In this particular day, now I have to decide what I'm going to go forward with. See, if I do buy on this particular day, whatever is the profit I'm gaining from behind, I'm going to subtract the price of the 1th day. So this I'm going to subtract from it. So this is what the profit I'm able to make if I buy on this particular day, if I actually buy. So -2 is going to be the profit if I actually buy. But if I, let's say, do not buy, right? If I do not buy, right, then if I'm not buying, I don't need to subtract the cost of this particular value here, right? Because I'm not buying, right? Whatever is the profit made from previous transactions, that I'm going to consider. Since I'm not doing any transaction here, any buying or selling here, I'll not be deducing this -2. Here I did because here I bought a stock, right? But here I'm not going to deduce anything. Which is better? Having a profit of -1 better or having a profit of -2 better? Of course, -1 is way better. So we are going to return this -1. Now you have to be very careful, right? Let me draw it like this. So -1. Now if we actually sell on this particular day, what is the profit, right? Whatever is the previous profit plus the profit, basically, since we are selling, plus the profit of this particular day. So what is the profit what is the price of the stock on this particular day? It is going to be 8. Now note one thing, that when we are selling, we are subtracting the price of that particular day. When we are buying, when we are buying, we are subtracting the price, and we are selling, we are adding the price of that particular day, since that comes into the profit, right? When you sell, that you add, when you buy, you will subtract. Simple, right? So now, one thing we have to consider here is that not only we are going to sell here, but every time we are selling, we are kind of completing a transaction. So we'll have to apply this transaction fees. So this -2 will also be applied here. And what will be the total value of this expression? The total value of this expression will be like 5, right? This comes down to 5. This is actually the value. If we actually, this is the profit till here, if we actually do sell on this particular day, right? Selling, if you are given an option that you have to sell on this particular day, what's the best you'll be able to make? You'll buy this day, you'll sell this day, -3 will be gone, like -1 since the price of this one, and -2 will be the fee. So -3 will be subtracted from the total of price, and the 5 will be the final price. But what happens if we do not sell on this particular day? Then the option comes down to this particular day. Then it comes down to whether we plan to sell on 1th day or not, right? Now on the 1th day, I can actually plan to sell, or I can ignore selling on 1th day. If I actually plan to sell, then the 0th day becomes the buy day. But if I do not sell on 1th day, right, the 0th day stays the selling day. Note, 1 means selling, 0 means buying, right? Again, simple scenario, kind of base case you can consider. From these two cases, since this is an invalid scenario, 0 cannot be a selling day, so 0 will be returned. And from here, whatever is the price of the 1th, 0th day, that is going to be returned. So price is -1. So since we are buying on 0th day, -1 will be returned. Buying means subtracting, right? Now if we are planning to sell on this particular day, right? If we actually sell on this particular day, This is the whatever value we're having from previous days, and we are selling on this day. This means that we're going to add it to, since we are selling, and since we are selling, we'll also have to apply this, transaction fees. So -2. It comes down to -1. The whole expression comes down to -1, and the best of both of these two is -1 versus 0. It is it is 0 only. So this returns 0 itself. Now consider this. What is a better option? Should we actually sell on this day, on this particular day, or should we not sell on this particular day? If we actually sell on this particular day, this is what the profit will be having. But if we do not sell on this particular day, 0 will be having. The best is 5 versus 0. The best is 5. So 5 is returned from here. 5 is returned from here. Now, since 5 is returned from here we were planning to actually sell on this third day. And if we were actually planning to sell on this third day, we are going to consider the price of this day, since we are we are buying on this particular day. Since we are buying on this particular day, 4 will be subtracted from here. We have bought the stock. We are not going to apply any transaction fee yet because we are not selling. Transaction fee only gets applied when we sell something. We are just we have just bought another stock. Now, in this particular scenario, let's say if we do not sell, right? Do not buy on this particular day, it will be turned over that, second day will be asked that if we try to buy on the second day or not. Okay. So second day has two options. Either we can actually buy or we can ignore buying. If we actually buy, it will come down to 1th day, and we will say that if we buy on 1th day, sell on 1th day. But if we do not buy on 2th day, 1th day will be asked this particular question. Note very important thing that, we have already calculated the answer for these two test cases before, right? This returns what? This returns 0 always. So here we are not going to again calculate this. This is dynamic programming. We are going to return 0 from here directly. 1 comma 0. What does it return? What is the best one? It returns -1 always. So it returns -1 from here as well. I'm not going to go in this whole tree again. This is dynamic programming. We are optimizing. We are optimizing, like basically we are not calculating what we have already calculated. So this is going to be returned. So from here we return 0, from here we return -1. What is the best of both of them? 0 is of course the best. So but one thing we need to consider is that, although this is a 0, right, we are planning to buy on this particular day. It will be a -2. -2 versus -1, which is better? Of course -1 is better. So here I'm going to return a -1. Now consider this. If we actually, this is turning out to be 1, right? What is better? Buying on this day is better, right? Or ignoring buy on this day is better. If I buy on this day, this is the profit I'll be having, right? After I cut the price of this particular day, or this particular price of stock, right? But if I do not buy, I'll be having -1 profit. Of course, 1 profit is better, so I'm going to return this. So we're going to return this one itself. 1 is going to be returned. Now 4,1, let's consider, right? 4,1, right? 4,1 was planning to sell on this particular day. Look at this closely, right? Here we returned a 1. Sorry, returned a 1. Now 4,1 we were planning to actually, sell on this particular day. I think it's not visible. I'll just bring everything down. Now it should be visible, right? So 4,1 on this particular day we were actually planning to sell the stock. This is the profit if I actually do from the previous people, like previous days. But since I'm selling on the 4th day, I'll need to add the price of this particular price as well. Plus I need to subtract the transaction fees as well because I'm selling, right? Okay. What is the total amount of all these things? It is turning out to be 8, correct? 8, 10 minus 2, 8, right? Now this is the overall profit if I do actually sell on this particular day. But if I do not sell on this particular day, third day will be asked that, let's say if I try to sell on the third day, have we actually calculated? No, we have not. So third day has two options. Either I can actually sell on this particular day or I can ignore selling on this particular. If we actually sell on this particular day, let me bring this down here. If we actually sell on this particular day, what will happen? What will happen? It will be, the control will be transferred to the previous day, but with what state? Buying state. And 2,0 returns what? It always returns -1. So -1 is returned from here. Why did I say that it returns -1? Because we've already calculated this. 3 comma 1, let's say if we do not, sell on the third day as well, the control will be transformed to what day? It will be 2 comma 1. Second day will be asked that, if you actually uh, are able to sell that. And 2 comma 1 is also already calculated. 2 comma 1 always returns what? It always returns 5. Right? So we are going to return 5 from here. I am not going again through the whole tree. I'm simply reusing what we've already done, right? So which is better? If I actually sell on this particular day, -1 is the profit from previous people. Third day is having 4. So plus 4 minus 2. Minus 2 means transaction fees. Plus 4 is because the third day is having a profit of 4. So what it turns out to be? It turns out to be 1. So this whole thing turns out to be 1. Which is better? 1 or 5? 5 is definitely better. I'm going to return a 5 from here. Now, tell me one simple thing. Selling on fourth day is better or not? Definitely 8 is the good answer. So 8 will be returned. And this was actually the final answer as well. Let's quickly reiterate on what actually the answer is meaning, right? We did sell, right? If you actually look at this closely, this tree closely, we did sell on the fourth day, right? We did sell on the fourth day, right? And from this particular scene, we can see that we did actually buy on the fourth day we sell. On the third day we actually bought the stock, right? On the second day we actually sold the stock. On second day we did nothing. We did nothing, right? And we bought the stock on the 0th day. This is the path which is the most ideal path. So buy on 0, do nothing, right? And here you can see, since this is tick mark, I'm saying that it's selling on the second day, buying on the third day, and then selling on the fourth day. I hope this whole recursive tree is clear to all of you. In this DP programming series, what I'm trying to achieve is I'm trying to make the whole recursive tree as much as I can in all the problems, because recursive tree is the most intuitive approach. And in interview as well, you have to first tell them the recursive approach itself. If this recursive approach is not clear, then there's no point of actually going into the interview itself. I'm not telling you the uber level details. I'm actually going inside the recursion tree and making the whole recursion tree. Videos are definitely longer, but they're longer for a reason, right? So let's quickly talk about the recursive code, then we'll talk about the memoization code, and then we'll talk about the tabulation code, and then we're going to end the video. So let's move forward. So code wise recursion is going to be straightforward. What we are going to do is we are going to create a function called public int recur, right? Int prices. And what are we going to send? Like prices is definitely we're going to send the parameters, index we need, and state we need. Okay, so let's talk about the base case. Base case was that if we are on index 0, if idx is equal to 0, what will happen? If index is 0, either state can be a buy state or state can be a selling state. And if state is equal to buying state, 0 state is buying state, I'm going to return minus prices of I. Else I'm going to return what? I'm going to return 0. Since I cannot sell on the first day, right? So profit will be 0 itself on the 0th day. This is the base case, and we are done with the base case itself. So 0th index is 100. Let's move forward. Now for other indices, we are going to move according to the state we are in. If we are in the buy state, we are going to do things differently. Else, if we are in a sell state, we are going to do things differently. Just for the sake of understanding, I'm going to write else if state is equal to 1. I can also do with state only, but I'm going to write state is equal to 2. Now, if we are in a buy state, there are two options. Either I can actually buy today. If I actually buy today, previous days will be prices array will be actually as it is. IDX -1, and since I'm buying today, I'm going off forward with this step here. The state will be changed to selling state for the previous days. And since I'm buying today, I'm going to reduce the prices of let me make it like this so that it's more. So if I do not buy today, recur of previous days, index -1 and state will remain the same. Since I'm not buying today, the state will remain the same. Moving forward, since I'm not buying today, I'm not going to actually reduce the price of this particular index because we are not doing any step here. What we're going to return actually is math.max of buy today, comma, do not buy today. The maximum of both of these values we're going to return. Similarly, for the selling state, we're going to simply say that if we actually sell today, if we are planning to sell today, then prices of IDX is what I have already gained, plus what? Prices of, sorry, recurs, basically previous days, whatever profit I'm able to make from the previous days. So prices array index minus one and state will be buying state because I'm selling. So state will be changed, right? Current state is one, right? Since I'm doing the selling operation today, for the previous days, the state will become zero. And I'll also have to reduce the transaction fee, right? I think I've forgot to add that here. In fee also you need to pass. Okay. So this transaction fee, wherever it is, I'm going to write this fees, wherever recur function is written. Correct. Here as well, I'm going to write transaction fee. Right. Okay. Yeah. So this is the profit we are going to make if you sell today. Int do not sell today. Recur of prices array, fee will be as it is, and if you are not selling index minus one, and state will also remain the same. So only index minus one happens when you are not planning to do the operation. Return what? Return simply math.max of math.max of sell today, comma, do not sell today. The max of this. Just for the sake of Java, right? I'm going to write 0 here. It's just the dummy return. We are not going to ever step on this return statement. Correct. Now let's call this function here recur. Prices area I'm going to pass. Price. Oh my god. Prices. Fee I'm going to pass. Index I'm going to pass as prices of dot length minus one. And state will be of course selling state for the last day. This will be considered as the best, state to be in the last day. Let's run this function. There is a compilation error. Let's see where it is. Prices of IDX. It's not I, it's IDX. Right. Accepted. But if I submit this, it is going to throw a time limit exceeded, right? Because it is not the optimized approach. If we are doing a lot of repetitive work here, time limit exceeded, we are going to use dynamic programming to reduce that repetitive work. If you are not familiar with dynamic programming, I would strongly advise to start the video from the start the you can say the problem solving what this DP series is from the very beginning, right? And then you'll understand that what actually dynamic programming is, correct? So let's optimize this quickly. Right? We always use a trick, right, in our problems. If you're not familiar with the trick, again, you should not watch this video directly. You should always watch this video as a part of this dynamic programming series. And trust me, if you once go, what I've done in this series now, I have, if you are new to this video and you're directly watching this video, let me tell you, in this particular series, I have generalized all the DP tricks for all the problems. So for every problem, I'm going to do this kind of step. So dynamic programming, once you think about the recursion, you will be able to do the memoization and tabulation as well. These are the tricks which I'm talking about. These tricks we have discussed before in the previous lectures of this dynamic programming series. So do actually watch this whole playlist itself, right? I'll just rename the function to memo. Wherever recur is written, I'm just going to rename it to memo. Correct. This is the new function which I've created, right? This is the memoization approach we are discussing. Here we are going to pass one more thing, which is the integer array, DP array. DP array. So remember and recall strategy, right? So if DP of IDX comma state, IDX and state is not equal to -1, I'm going to return DP of IDX comma state. This is the recalling strategy. We are not going to go ahead if we actually have the value for that particular index itself. But for the recall strategy, we're going to do DP of IDX state. This is the remember strategy, sorry. So here we remember the answer, and in future, let's say if we try to access this particular state, we recall this answer, and this actually solves the problem itself. So here, wherever memo is written, I'm going to add the DP array as well. From here as well, I'm going to add the DP array. Here as well, I'm going to add the DPL. Right. Okay. So this is done. Right. Let's call the, I'll just keep it like this only. I'll just write in DP array. We have to initialize the DP array here itself. New prices dot length, and this number of states are 2 only. So for int I is equal to 0, I less than dp dot length I plus plus dp of I 0 is equal to minus 1, dp of I1 is equal to minus 1. Since we are so the internal arrays are only of length 2, I'm initializing everything with minus 1s. Right? Minus 1 mean that we have not wasted that state. I hope that is clear by now. Correct. We're going to return what? We are going to return memo. Prices array we are going to give. Fee we are going to give. Index prices dot length minus 1. And what else? What else? We need the state and DP array. State is going to be 1, selling state, and DP array is going to send as it is. So this is the whole memoization approach. So quickly we converted this to memoization. If this approach is not clear and you're having a lot of doubts, trust me, you'll not be able to understand in further lectures as well. Please watch the previous lectures to understand this trick. Now if you submit the problem, it will simply get submitted. It's getting accepted. Right? So this was the memoization approach to solving this problem. Let's talk about the tabulation approach as well. All right. So for tabulation approach, it is pretty straightforward. What we actually do is we create a different function, public int tabulation. Int prices array will be passed here, prices. Fee will be passed here, and int DP will also be passed here. Is actually correct. Now for this particular case, this particular array, simple thing which we are going to do is since we are DP array is also going to pass. Remember, tabulation is not top down; it's bottom up. So you are going to start the loops in reverse order. Correct. What loops you say? The loops are pretty straightforward. It is going to be whatever is your from the base case to whatever is your final state is. So how many loops you ask? Our recursion is having two parameters, right? Mainly index and state. So two loops will be going to be there. For int I is equal to 0, I less than you can say prices dot length I plus plus, and here we are going to have for int state is equal to 0, state less than 2, state plus plus. Or you can also since state has only good video, so we're going to say 2 only, right? Instead of I, let's call this idx. It will be more close to our recursive thing. Correct. Okay. All right. Now what we're going to do inside these loops is we are going to simply copy paste this memoization code. Just copy paste this memoization code again. Just copy paste this memoization code. Okay. So this is memoization code we were talking about, correct? All right. So now we need to format this memoization code. Wherever return statements are written, right, you'll have to write continue statements, right? One thing actually we can do, we can ignore the index 0 case. We can ignore the index 0 case here, and instead of this index 0 case, we can start the index loop with this, right? And here we can actually initialize dp of you can say 0 comma 0 with minus prices, or let me do it normally only, right? So the normal strategy is wherever return statements are written, just you have to set the value dp of what idx comma state second state is equal to this value. Here as well, you're going to say dp of idx comma state is equal to be this value, and I'm going to continue from here. Wherever return statements are written, you have to continue from there. For example, like this state, right? If this statement we can remove, the recall state we can remove, right? Where else are we having return statement? Here we are having return statements. I'll just remove this return statements. I'll just remove this return statements, and it will automatically translate to continue. So this is the last line of this statement, right? It will automatically go to continue state, right? Here also we are going to return. I'm just going to return this dummy return statement, right? Okay. Now Other than this, wherever we are writing, accessing this particular thing, na, DP, like we are calling the memoization function, we are going to call the DP, array here itself. So what I'm going to write is DP of something something. I need to provide parameters. What parameter of index I'm passing here? Exactly, I'm going to pass here. What parameter of state I'm passing here? Exactly, I'm going to pass here. And I can simply remove this memoization block from here. Here again, right? I'm planning to write DP of something something. Right. What state am I passing here? IDX minus 1. So again, here also I'm going to write IDX and state will be 0. So here I'm going to write the state. This we can simply ignore. Correct. Here is, of course, we are setting the current state. And again, like here we are going to replace this with DP of something something. DP of something something. And what are we talking about in terms of this? Index will be the first parameter. 0 will be the second parameter. And this is the thing they're having, right? Similarly, here as well, index minus 1 and 1. So I'm simply going to return this directly. Copy this, paste this index minus 1, and I'm going to write 1 here. Correct. And in the end, where will your answer lie? Return DP of prices dot length minus 1. Basically, what we are calling here, right? Prices dot length minus 1, comma 1. So 1. This will be your answer. Okay. So instead of just doing this, let's call return tabulation. I'll pass prices array, fee here, and DP array. These three things I'm going to pass, and this is the actually tabulation code. If you are not getting this trick now, my friend, please watch the previous videos, else these tricks will not be clear to all of you. Okay, something is missing, but int found. Okay, array required but int found. Okay, let's see what's the error coming out to be. If state is equal to 0, okay, I think okay. All right, let's try to run this again. Oh, we run this again. These kind of things. Let's see. Okay, I think yeah. Here I did a mistake. I didn't give the parameters for DPL. This should be resolved. Accepted. Let's submit this. See what it comes out to be. Accepted. And we are able to solve this problem very beautifully. Right. All three approaches, recursion, memoization, tabulation, are here. Please feel free to ask any doubts if you have in the comments. Right. Time complexity wise, it is going to be in, if we talk about the time complexities, right? Let's say in memoization scenario, it is going to be linear only. And in this tabulation scenario as well, it's going to be linear because states are only 2, right? So n into 2, which is 2n. So it will be n only. But in case of recursion, it will be actually, I guess it will be 2 raised power n because we are doing 2 calls, per, you can say per level, right? So 2 is power n, and I'll discuss about recursive time complexities as well in some future videos, but 2 is power n is going to be the time complexity for this recursion. Correct me if I'm wrong in the comments. If you have some different views, do let me know. Correct. I hope this question is clear. You're going to find this code in the description of this video. In fact, every video you're going to find the link to the repository where all the solutions are present of all the videos. Correct. I hope you all enjoyed the lecture. I hope you are going to share this lecture itself. I'm working hard on completing this series itself. So thanks a lot everyone for joining, and I hope you enjoyed the lecture. Bye.